Hello everyone. In this video we will discuss finding domain and range graphically, parent functions, and how we can use parent functions to help us find the domain and the range. So real quick, the domain is the set of all the possible y values. I like to think about those as my inputs. What could I put into the function or the relation? Range is the set of all the possible y values. What values are the outputs? So after you put something in, what do you get back out? Now we can think of this visually when we look down here at the graph, and we can see here is my relation. In fact, this is a function, and we can see that this has the x values that range from -13 all the way over to 10. So those are the values that this graph could take on as inputs, and we can see those in blue. And we want to think of those as left to right. Range is the y values, or all the output values that we could see. And we can see those in red. We see our lowest value is -5, and it continues all the way up to 8. Interval notation is always written from low to high, and it can either have brackets or parentheses. The bracket means that it's inclusive. The non-bracket parenthesis means that it is just a non-inclusive. So let's take a look at our first example. Here are some ordered pairs. And we can just drag these around so we can see, again, the x value is talking about our domain in blue. The y value is the range, -2 in this scenario. So we can see this visually how it maps out. And if we move around to all these different points, we can see what are the possible x values and what are the possible y values of this function. Well, makes it nice and easy. The x values could take on values of -5, -3, -1, 2, 4, and 6 right here. Well, the y values can take on -2, 0, 2, 4, and 5. And we can see that, and we'd write this out, because these are each ordered pairs, so we'd write this just in set notation. So we see -5, -3, -1, 2, 4, and 6. Those are all the blue values. And all of the red values are -2, or the y values, 0, 2, 4, and 5. Let's try another one. In this case, we again see this function that we talked about earlier. Now I'm going to drag this point. Now as I move this point around, these are all possible values that this function could take on. And you'll notice two things. The blue is expanding. That means as I move left, we see there are more possible input values. As I move right, the blue line is going to the right. There are more possible input values to the right. And likewise, we see the outputs varying. So we can see as I drag this point, they are highlighted. So the blue is going to give me all of my domain values. So we can see this function from left to right goes from -13 all the way till 10. Now we see that that is inclusive. There is the point -13, there is the point 10. So my domain would be from -13 to 10. Inclusive. Now the range, again, now we can think low to high like an elevator. We'd get on at the bottom and ride it up. We could see that it would start at -5. That's our lowest y value. And the highest y value goes all the way up to 8. And we can see it takes on all those values because the red line is consistent. This function's a little bit trickier, so let's take a look. So I'm going to move my point, and we can see the blue. As I move to the left, the blue is going to the left, and we see the y values going up and down. We can see that this is going to go on forever. I come back this way, and again, as I trace all the possible inputs and outputs or solutions to this, we can see my domain and range. Now notice this time that this says there's an arrow, so that continues on forever to the left and forever on to the right. So my domain then would be -infinity to infinity. But the range this time is going to be different. We can see that the range doesn't go from -infinity to infinity, but my lowest y value is right here at -1, and it goes all the way up to 3. Now it touches at -1, and it touches at 3 by the closed circle, so we can have it be inclusive. Well, what about if it's not always inclusive? So again, if we drag this one, we can see how this works out, and we can see some things happen here. Now here's my minimum. And we can see we're going up, up, up. Now notice this goes up forever. So as I keep going up, I would also keep moving to the right, and it would go on forever, so we would see that the domain would continue to the right forever. Now, when we look at the domain, how far left can it go? Well, it's at negative 1, 2, 3, 4, 5, negative 6. But what do you notice? It is an open circle at that point. That means it is not inclusive. I couldn't put negative 6 in the function, so therefore, my domain would be negative 6 with a parenthesis. So we see that we have that. Now, what that means in interval notation is it means it can be everything really close to negative 6, but not quite negative 6. And it continues to the right forever, which would be infinity. Now the range, again, low to high, our lowest value, we can see it is at negative 4, and goes on forever. But you might say, wait a second, this is an open circle right here at this point. And you would be correct. But if I look at all the possible output values, notice at that same spot, which is y equals 2, the function is defined. It's just not defined here, but it is defined over here at 4. So it is going to be from negative 4 to infinity with no breaks, because although it's not defined in this spot, it is defined in that spot. Okay, last one. Now this one's already dragged for us, so we don't need to move it around. But if you want to take a second to try that, pause the video to see if you could get this one. But what we notice here is we see an open circle and a closed circle. So let's think of domain. How far left can this function go? Well, it can go to negative 5, but it can't touch it. So we have an open circle, and it could go all the way over to 8, and we can see that visually. So my domain will go from negative 5, not inclusive, to 8. What about the range? Well, look, how many y values do I actually have? And if you look, there's one red dot which tells us that the range is only 3. So sometimes people get a little tricked up with this one, but other than that, it's not too bad. So again, we want to think domain are left and right, all the possible inputs are x values, the range are all the possible output values. Well, sometimes what happens if they don't give us the graph? That's where we're going to use our knowledge of parent functions, or eventually we'll do sketches to help us out. Now I'm going to briefly just put this up, but this is a video, so you could pause it. If you don't know all of your parent functions, please go back over these. We've got y equals x squared, a cubic, a square root function, and all their domains and ranges, cube root, and absolute value. We will do more this year, but this was just enough to fit in the video. And like I said, if you don't know all these, please pause it and just try to remember those. If you know your parent functions, then we can use our transformation rules to help us out and help us move it around. So we have a vertical translation happen when we add any value on the outside of the function. And I always like to think, because that affects your outputs. You would put a number in, you would do an operation to it, and then you would add some constant. And that's going to shift this function up or down, a vertical translation. An example might be y equals x squared plus 2. Notice the plus 2 is outside the function. So whatever you inputted into this, you would square it, and then you'd add 2. So that's going to shift the y values. It's not going to have any effect on the x values. So this would shift up 2. On the other hand, x cubed minus 4, which would be, again, on the outside, so it's affecting your outputs. So that tells us that it would shift this entire graph down 4. Well, we can also move a graph left and right, our horizontal translations. That is going to be, if you notice, on the inside of the function, f of x minus h. So we see it's now on the inside, affecting inputs, and inputs being left and right. So y equals the absolute value of x minus 3. Now this one's a little tricky, but we see it's on the inside, and that is going to shift all of our values to the right by 3. This video is not going to explain all that, but if you wanted to check out another video, please feel free. But this function is defined, the translation is defined as x minus h. So as I say, x minus 3, that's telling the translation to the right by 3. Y equals the square root of x plus 1. Again, inside, affecting inputs, and it's the opposite of what you think. It's a positive 1, but it's shifted left 1. We can also do vertical stretches and shrinks. That's where I'm going to take all my values and stretch them out vertically thinking outputs. So again, notice I'm multiplying the function by some constant a. Where's a? On the outside, so it's affecting your outputs being y values. So y equals 6 times the absolute value of x, you'd put a number in, take the absolute value of it, and multiply by 6. So it's going to be 6 times as large as when you started. that's going to give us a vertical stretch by a factor of 6. And a lot of times we just say that that looks skinny compared to the parent function. Whereas y equals 1/2 cube root of x, again, it's on the outside, so the outside, so it's going to affect the outputs. So this would give us a vertical shrink or make it look a little fatter by a factor of 1/2. We can also do reflections by putting a negative on the outside affecting the outputs. So again, if you think about it, you put a number in, you do an operation, then you make it the opposite. That's going to make that reflect over the x-axis. Whereas if we put a negative on the inside of the function, that's going to affect our inputs, which are the x values, so therefore it would reflect over the y-axis. So let's just try a couple of these real fast. I am at home with a mouse trying to do this, so it's not going to be the greatest thing, but that's okay. So the first one that we have, y equals x squared plus 4. So let's list the transformations. Well, the plus 4 is on the outside. It's going to affect the output, so that's going to shift it up 4. Alright, so let's go ahead and shift it up 4. Now it's a quadratic, so we know we're going to go here. It was a 0, 0. It's going to go to 0, 4, and it's just going to open up. And this is just a quick sketch. Okay, so what's my domain? Well, how far to the left would this thing go? Well, it keeps going up and up and up forever, and if you remember from the graph, our activity, we would see that it would keep moving over the x values. So my domain would be negative infinity. And how far to the right would it go? Well, it's going up but moving to the right, so it would keep going to the right forever, which would also be infinity. So we can see there is our domain. Well, what about the range? So now let's take a look. What's the lowest y value that we have? Well, we said it was shifted up 4, so 0, 4 is our minimum, so the minimum point is 4. And did the function touch it? It sure did. That's the vertex. And it would open up forever, which would take us to infinity. So there's our domain and range. And again, feel free to pause this at any point and try them yourself and go back and see if you got it right. Okay, so next one. This is absolute value of x minus 3 and then minus 2. So what we see happen now is we are going to be doing two transformations. Number one, x minus 3, that's on the inside of the function, so therefore it's going to shift it left and right. So this is going to be shift right 3. And then the minus 2 is on the outside, so it's going to be down 2. And it's an absolute value function. So we're going to go right 3 from 0, 0 and down 2. So there's my vertex. It's going to open up in its absolute value, so it's just going to be a v. And again, it's a quick sketch. So that point right there is 3, negative 2. Sorry, it's a mouse. Okay, so let's do domain. So again, how far left is it going to go? Well, this is going to keep moving left forever, so negative infinity. How far right? Also going to go to infinity. Now be careful, it's going to infinity now because it's going up because it's moving to the right. In the range, my lowest value that we could see goes from negative 2, how far up? To infinity. So negative 2, did it touch it? It sure did. How do you know? Because if I put 3 in this function, it would give me out negative 2. So negative 2 to infinity. Alright, next one. Square root function, square root of x minus 6, and we have the negative, so on the outside. So again, outside affects the outputs. So this is going to be, we got the x minus 6 on the inside, which is going to affect our inputs. So we're going to move it right 6. And we're going to, actually, if we're doing this the right way, we're going to do the reflection first. So we'll reflect, it's on the outside, so we're going to go over the x-axis, and then we'll move right 6. And again, I'm not going to go through all the steps because this is just a review, but we're going to reflect first and move right 6. So here we go, and then it's going to reflect over the x-axis, so it's going to hook like that. Okay, so what's my domain? Well, let's look left, right now. What's the smallest x value we could put in? It's right here. The smallest value we could put in is 6. Does it include 6? And the answer is yes. And why? Well, could I put 6 into this function? Yeah. 6 minus 6 is 0. What's the square root of 0? 0. So that gives me an output value. I couldn't put any other value in, like negative 5 for instance, because that would give me negative 1. And that would give me, 5 minus 6 would be negative 1. Square root of negative 1 is I, so it's imaginary. And we're going to keep going right forever, so infinity. Well, what about the range in this scenario? Our lowest y value this time, now it's tricky. Now this is pointing down forever. So it's going to go down forever. And so if we think about that, it's going to be like the video, it's going to be going down this way forever if I tracked it. So my range would actually be negative infinity to 0. And again, it would include 0. And you might say, why? At 6, if I plug it in, the output value is 0. All right, 3 more. Okay, so now we got a couple of things going on here with this one. So let's go ahead and do it. So first thing, we have a 1/2 on the outside. So that's a vertical, that's going to give us a vertical shrink. It's going to make it fat. We're going to move it left 1 because of the x plus 1, and we're going to go up 3 because on the outside. So the outside affects the outputs, inside affects the inputs. And now this is a cube. This is going to be a bad drawing, just so you know. Left 1, up 3, that's kind of where the center is. And it's 1/2, so it's going to make it look fat, and it's a cubic, so it's going to look like that. I actually did a pretty good job. So let's think of domain and range. How far left? Well, this thing's pointing to the left forever, so it'd be negative infinity to infinity. Think up and down, it goes down forever, up forever, all real is negative infinity to infinity. There we go. Okay, next one. 2 cube roots of x minus 1, so we can now see that the minus 1 is on the outside, so that tells us that it's going to go outputs, down 1, and we're going to have a vertical. In this scenario, we're going to have vertical stretch because we're taking all the outputs and multiplying by 2, so they're going to get bigger. Okay, so let's think about it. So we're going down 1, so what's 0, 0? Now it's at 0, negative 1. And cube root looks like this, so I'm just going to make it stretch a little bit. There we go. And again, these are just sketches, so you're just getting an idea. Alright, and the last one. Here we go. So, first thing we're going to do, negative on the outside. Reflect over the x-axis. Always do that first. Then we've got a vertical stretch because of the 4. X minus 5 tells us we're going to shift right 5. And the plus 2 on the outside tells us we're going to go up 2. So here we go. Going to go right 5. So right 5, up 2. Okay, there we go. Tells me that it's reflected over the x-axis. So that means it's going to go up and down, and it's going to be a vertical stretch, so it's going to be super skinny. But again, it's hard to tell when you do this because it's just sketching. Later we will do graphing. So how far left and right? Negative infinity to infinity. And the range is going to leave us with now low to high, so it's going to go from negative infinity. And the question is, how high up does it go? It goes up 2, so it would be 2, and it's inclusive on the 2. Alright, well thank you guys so much for watching this video. Hope you found it helpful, and feel free to check out more resources or watch the video again and try them yourself.